Okay, so today we're going to talk about real numbers. Did you know there's a thing called imaginary numbers? Has anybody heard of that? Somebody say yeah? You have? You've heard of it? Okay. They exist. Okay, there's a real number system and there's an imaginary number system. Now the imaginary numbers you don't learn about until like Algebra 2, so you've got a little while. But the real numbers we focus a lot in Algebra 1 on those. It's actually amazing the stuff you can do with them, but it goes a lot more in depth later. We just learn the basics. Okay, so in the real number system, every number in the real number system you can classify as a rational number or you can classify as irrational. It's going to be always one of these two. Okay, a rational number, that means you can write these numbers as a fraction. Irrational numbers are numbers that it's not possible to write as a fraction. So we're going to write a few notes over here in this empty space. Don't write too big because we're going to write a little blurb for each one of these words so you'll remember them a little more. Okay, so the first one we're going to write down is rational. Okay, and I'm going to zoom this in a little bit so you can see what I'm writing. But rational, is any number that you can write as a fraction. Okay, when I'm writing my notes, sometimes I abbreviate a little bit. Okay, so we all know what this means. Okay, not hashtag, it's number. Okay, any number that can be written as a fraction. Oh, that's messy. Okay, rational numbers are any number that can be written as a fraction. But what I want you to do is look over here in this diagram that I gave you. So I have negative 9/2, I have 3/4 in there. What about these two? Are those fractions? No, they're not fractions, but you notice the definition, it says that can be written as a fraction. Okay, a repeating decimal and a terminating decimal, those can both be written as a fraction. We'll talk about that more later, but it is possible to write both of those as a fraction. Okay, so underneath this, I want you to just write in parentheses, this includes terminating and repeating decimals. Okay, so you notice over here with the big circle, with the rational numbers, there's other types of numbers within this circle. If a number is rational, then it can be other things. It can be an integer, a whole number, or a natural number. I feel like y'all have heard the word integer before. Is that correct? Okay. Integers. You see my number line up here? That's any number on the number line. Okay. So you notice there's no fractions or decimals up there. Okay. It's only whole positive numbers, whole negative numbers, and 0.
Is natural or only positive numbers?
Yes. Yep. Okay, so integer is the whole number line, negative and positive. Okay, so this is how I write it, just so I can kind of remember. It goes on forever in the negative direction, forever in the positive direction. Okay, and continues this pattern. Okay, now whole numbers and natural numbers, those are almost the same thing.
Whole number 0.
Yes. Okay. Whole numbers include 0. Natural numbers do not. Okay. So integers, those are the whole thing, the whole number line. Whole numbers are from 0 on this way, and natural numbers are from 1 and continue to the positive. Okay. So whole numbers and natural, almost the same thing, but whole numbers have 0. Okay. So for whole numbers, I'm going to write 0, 1, 2, 3, and so on. And then natural starts at 1. Okay, so I'm going to highlight these words because these, I need to make sure these definitions stick out to me. These are definitions that I need to know. Okay, and then you notice irrational, it's over here kind of all by itself. That's because if a number is any of these over here, any of the rational, integer, whole, natural, then it cannot be irrational. It's going to be one of the two, either rational or irrational. Okay, so if rational numbers, those are numbers that can be written as a fraction. What's irrational? Can't be. Okay, look inside the irrational circle for a second, though. So, irrational numbers. It includes numbers that go on forever and ever without a pattern. Okay, decimals that go on forever and ever with no pattern. But notice what else is in here. Pi is in here. We know about pi. Okay, 3.14 goes on forever. Square root of 2. The square roots get a little confusing. I'm hoping that we all know our perfect squares. Do we? You memorized those last year. Perfect squares consist of 4, 9, 16, 25, 36. What's next?
Oh, like 5 to the 5th power.
Or anything to the 2nd power.
Oh, to the 2nd.
Is perfect square. So like 2 squared is 4, 3 squared is 9, 4 squared is 16. What's 5 squared? 6 squared, 7 squared, 8 squared. Okay, all of those numbers are perfect squares. So if you're ever taking, what?
1.
Oh, 1, 2, yes. If you're ever taking the square root of a number that's not a perfect square, it's going to be irrational. And you can check this with your calculator. Everybody get out your calculator for a second. Are you Kenna? Everybody look up here. Let's make sure we all know how to do this. Okay, if I'm taking the square root of a number, I know it's blurry. The square root sign is right above the x squared. You see it? I'm going to hit second, and then that button, and then 2. I'm taking the square root of 2. So I get this long number, goes on forever, no pattern. That tells me what? It's irrational. Okay? So if you ever need to check with your calculator, that is okay. Like if you don't feel confident you remember all the perfect squares, that's okay. We always want to check. But if I take the square root of like 9, That's 3. So that number is irrational or rational?
Rational.
Rational. Okay, and it's also integer, whole, natural.
What's pi?
Pi is irrational.
I know, but what number is it?
3.14 something.
But like, what can you put in to like make it?
Oh. There's a pi button on there.
22 divided by 2.
Yeah, well, 22 divided by 7 is an approximation.
Forgot all those baby times.
Isn't there a pi button on there? Oh, here it is.
That was so funny.
Let's get pi and enter. Okay, let's look at some examples. Also, this is something that's helpful to highlight. Don't forget a number can fit into more than one category. Okay, more than one group. If it's rational, it can also be other things. It doesn't have to be, but it could be. Okay, 56 over 7. First, I try to think about, is it going to be rational or irrational?
It's
Okay.
rational.
Rational could be a fraction. Irrational, it's not possible to be a fraction. Okay, well this is obviously a fraction, so it's rational. Okay, but what's confusing is they have integer, whole, and natural listed. I thought those were just numbers on the number line. How is this an integer? Jenna? Okay, what whole number does this equal? 8. Okay, always try to simplify. So this one I can simplify. 56 divided by 7 is 8. That tells me I can do a little more. Okay, it's on the number line. It's an integer. It's 0 and above. It's whole. It's 1 and above. It's natural. Okay, negative square root 64. Try to simplify. Put it in your calculator if you need to.
It's negative 8. So
Negative
it's
8.
Rational and
Okay? Does anybody know, because we talked about rational numbers are numbers you can write as a fraction. How do you write negative 8 as a fraction? Anybody know? Yes. Hey, if I'm writing negative 8 as a fraction, then it's negative 8 over 1. Hey, any integer, if you want to write it as a fraction, just write it over 1.
next one's
Okay, and then square root 28. If I put this in my calculator, okay, I get 5 point what? 291 ... Okay. It goes on forever with no pattern. This little wavy equal sign. Yes, thank you. This means approximately. Okay, I couldn't write the whole thing, so I wrote a wavy equal sign. It's approximately this, which means it's irrational. Okay, I want you to try some of these on your own. I have 9 listed at the bottom. Before you start, though, I want you to notice I gave you abbreviations that you can use. Y'all see these? You don't have to write out the whole words. Why am I not letting you use I for integer? Okay, because we have irrational as well. I want you to do the first 3 letters for both of those. Okay, go ahead and get started. I'll come around and help you, and you can talk to your group members as well. You really don't need it. There's only one. You're fine. Don't forget, every single one of these numbers should be either rational or irrational. Okay, that one of those is always going to be in your answer.
Do we have to like do 2 of them if they're both?
Yeah, so you could have 1 answer, 2 answers, 3 answers, or even 4 answers.
It's not natural.
Yeah.
Oh, yeah. Oh, the evening cookies.
He's competing.
Chicken.
It's so good.
It's rational.
Dude, is this something wrong with one of those or something?
Yeah.
What's wrong?
You think you know this is gonna take, right?
Are you different?
No.
Have you ever served it? You good for serving?
Hold on, I got
This isn't that.
I'm right.
Wait, you said they could be fun.
No, I didn't. Yeah, I was
Alright, you should be done in about 2 minutes. Yeah, about 2 minutes.
You want to sit back or no?
No, just the front bottom part.
That's how you solve it. How you win.
These cookies make you hungry, right?
Them cookies.
Yeah, look at the screen. Look at the middle, at the bottom.
Bottom left or right?
No, in the middle. The middle at the bottom.
Oh yeah, it is. We're still recording. Them cookies.
Yes.
Oh, it's right there. No, he's right in my mouth. No. I don't eat Oreos.
Alright guys, let's start. You have a question?
Yeah.
Okay, I'm gonna call names. Okay, if you need help, call on somebody in your group to help you out. Okay, when I call your name, if the that number has more than one answer, just tell me one, and I'll call on somebody else for the next one, okay? All right, Josh B. Number 1, tell me one of them. Rational, great. Okay, number 2, Sam. Oh, wait, no, we're still on number 1. Tell me another one for number 1.
Integer.
Perfect. Does number 1 have any other answers?
No.
No, because it's negative. Okay, we're done. Number 2, Jenna. Great. Okay, Reagan. What else for number 2? Whole. Okay, good. Okay, still on number 2. Chance?
I don't have any others.
Think about is 0 on the number line? Okay, if it's on the number line, what does that tell us? Integer. Good. Okay, rational whole integer. Okay, make sure you get all of them. Don't leave any out. Okay, number 3. Ashlyn? Rational. Good. Drew? Good. Another one, Caleb? Huh? Whole? Good. And one more, Gracie? We already got that one. Natural, yes. Okay, so sometimes we could even have 4 answers. Okay, number 4 is where it starts to get a little tricky. Cat, what'd you get? Rational, good. And that's it. Okay, I know it's not integer, whole, or natural because when I look up at that number line, I don't see 2/3. Okay, that's it. Okay, Patrick, number 5.
Rational.
Good. And that's it. When I look up there, I do not see negative 1/5. Okay, number 6, Kenneth.
Rational?
Good. And that's it for that one too. Number 7, Andrew. Okay, because this one is called a terminating decimal. Remember, that's part of our rational definition up there. It includes terminating and repeating. Okay, number 8, Nick.
Irrational.
Good. Pi is always irrational. And number 9, Lacey. Good. Okay, because 7 is not a perfect square. And I'm just going to add one more on here. What about this one? Say we're just going to add a number 10 down here.
Do we have to write them?
If you want to. 2.7 repeating.
It's rational.
Rational. Okay, rational numbers include terminating and repeating decimals. That would be rational. Alright, good job. Any questions before we move on? Okay, the back side is a little easier. I feel like we had the hardest part first. Okay, so on the number line, we can actually do rational numbers too. I know the number line I have in here is just integers, but we can actually do fractions and decimals on the number line as well. Like, for example, you could count by thirds, like 1/3, 2/3, 1. 1 1/3, 1 2/3, 2. Okay, like that. And also, when we're listing the numbers on a number line, we use braces. Okay? Braces are those like wavy parentheses. They look like this. I'm not that great at drawing them.
Oh, those things.
I understand you may not be that great at drawing them, but as long as it's not like a straight parentheses or the brackets, I just need to see that you're trying your best to draw those.
A bird.
A bird?
You draw like a 3?
It's like a sideways bird.
Squaw.
Yeah.
Squaw.
Just trying to make it look like a long 3.
Oh.
You know what I mean? Just do your best. I understand we're not great at drawing them. I get it. So now, when we list these numbers, we have -3, -1, 1, 3, 5. We put commas in between them, then the braces on the outside. For B, I'm going to highlight this because I think it's helpful. Look at this end of the number line. You can barely see it, but do you see that this is shaded a little bit darker than the other end? You can barely see it. You got to look closely. Okay, what that means is, since it's shaded, it means the pattern continues. Okay, we show that by doing an ellipses. Do y'all know what that is? That's the dot, dot, dot. Okay, you have to indicate that when you write this number set. So that shows the pattern continues. A lot of people forget to do that. Okay, look over here at example 2. This is already completed for you, but there's something important I want to point out for you. Notice the numbers are -3, -2, -1, 0, 1, 2. So we put points on all those. Why is there a point at -4? The pattern continues. That's what the ellipses means. The pattern continues. So yes, the arrow is shaded on the end like it's supposed to be, but there's also a point at -4 because the pattern continues. Okay, and then
skip -4.
no, they just didn't list it here, but this dot 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 shows the pattern continues to the left. So they put one here, a point here, because the pattern continues. This is what they gave us, and then the number line is the answer.
So if the pattern doesn't continue, if it's not like that, then you don't have to do the dot.
Right.
Dot.
Yeah, but if the pattern continues, go ahead and put a point here, and then also to the shaded arrow at the end. Okay, let's try number 1 and number 2. We can just do these together real quick. Number 1, I want to do the brace. I don't have either arrow shaded, so I just list the numbers that have the points on them. So I have -2, comma, 0, comma, 2, 4, 6, and then another brace. What about number 2? Do I have either arrow shaded? Okay, on the right side. So I need an ellipses on the right side. So I'm going to have the brace. 1, 3, 5, 7, and dot, dot, dot.
It's easy.
Yeah, this part shouldn't be very hard. Just sometimes when people do it too fast, they don't realize an arrow is shaded. Okay, and then the last part of today's lesson is absolute value, which you've done before. Absolute value is the distance from 0 on a number line. So you can do absolute value of numbers that are fractions and decimals as well, because it's just saying how far is a number from a number line. But think about distance. When I'm talking about distance, am I ever going to use negative?
No.
Okay, like if my house is 2.5 miles from here, I would never say it's negative 2.5 miles. It's just 2.5 miles.
How is that possible?
It's not. That's why you don't write it. Okay, so for example, if I have -7, how far away is -7 from 0? How many units?
7.
7. What if I have -8.5? How far is -8.5 from 0?
8.5.
Okay, we just make it positive. Okay, the ones that tend to be tricky on here are the ones where we have expressions that we have to evaluate. On here it says evaluate 4 plus the absolute value of x minus 2 if x is equal to 5. So first thing you do is substitute in. We put the 5 in. Next, evaluate what's inside the absolute value bars first, and then take the absolute value. So simplify it inside the bars first, and then take the absolute value after you've done that. So 5 minus 2 is 3. Absolute value of 3 is 3. 4 plus 3 is 7. Okay, let's do number 1 together. So it says y is equal to 2.5. When you are doing this, make sure you draw your absolute value bars big enough so they don't look like 1s. So you don't want that to look like 14. Okay, so work out what's inside the absolute value bars first. I'm going to have 18 plus the absolute value of 1.5.
So it's 19.5.
Because the absolute value of 1.5 is 1.5. And then when I add those together, I get 19.5. Oh no, I do not see people with calculators on that. Come on. Not to call you out or anything, but we don't need those. Okay, number 2. Okay, so B is 1/4. So I'm going to have the absolute value of 1/4 plus 1/4 minus the absolute value of negative 1/2. So remember, evaluate what's inside the absolute value bars first, and then take the absolute value of it. What is 1/4 plus 1/4? 2/4 or 1/2. Okay, now I can take the absolute value of each part. The absolute value of 1/2 is 1/2. The absolute value of negative 1/2 is 1/2. So I end up with
0.
1/2 minus 1/2 or 0.